What is up, Algebra 1? This is lesson 97. Our objective is, how do you graph linear inequalities? Well, before we talk about graphing linear inequalities, let's just do a quick recap on how we graphed single variable inequalities. And if you had in this form, like x is greater than or some number, remember if you had a less than or a greater than sign, then you'd use an open circle. And if you had a less than or equal to or greater than or equal to, then you'd use a closed circle on the number. And if you had less than or equal to, then you would shade to the left, right? Numbers smaller than that. And if you had a greater than or equal to, then you'd shade to the right, bigger numbers. Okay? Also, you need to remember how to graph lines in the form y equals mx plus b. Remember, m is the rise over run, and the b is the y-intercept. So now let's take what we just talked about right here. Let's talk about linear inequalities. So now, since we're having a whole line, and not just a number line, we've got a coordinate grid, we're going to be either using a dotted line or a solid line, just like we use an open circle or a solid circle. So dotted line is like an open circle, solid line is like a closed circle. And then over here, where we shaded smaller numbers, to the left, we're going to shade below the line. Again, smaller numbers, or smaller sets of numbers. And if we here, where we shaded to the right for bigger numbers, here we're going to shade above the line, where again you have larger sets. And if you want to think about the side you can't walk on or the side you can walk on. So let's see about here. Let's see if we can graph one of these. So first of all, I'm going to start off with a y-intercept. My y-intercept is up here at 3. I got that from right there. My slope is negative 1 over 2. Since I know it's negative, I know I'm going to be going downhill, right? So my rise, I'm going to say, is negative 1, and my run is over 2, so I'm going to come down 1 and over 2. Give me another point. Down 1 over 2, down 1 over 2. And I'll start to get several points here that form a line. I can also go up 1 and left 2 to get these points. And then I'm looking right here, and I know that I should have a solid line. So then I'm going to connect these as best together. Whenever you're doing this on a piece of paper, you should probably use a ruler or a straight edge of some kind to make those lines nice and straight. And then, so since this is or equal to, that means any point along this line will make this true. So that's why I colored in solid. Now, think about I need the y to be bigger than this stuff over here, so it's going to be values up here. So I'm going to shade all up here. And normally I'd turn like my pencil on my side and shade like with the side of my pencil whenever I'm shading this by hand. You can shade above. Now, what does this mean? What did I just do? I did something, but what did I do? What I'm saying is that any point in here, I don't know, maybe this point right here, 2, 3, if I plugged this point into this equation, it would be true. Let's illustrate that real quick. So the y is 3. I'm trying to find out if this is true. Is 3 really greater than or equal to negative 1/2 times 2 plus 3? So is 3 bigger than or equal to negative 1 plus 3? Is 3 really bigger than or equal to 2? Well, yes, that comes out to be true. And in fact, any point in the shaded region or on this line will make that equation true. So before we were just talking about the points that made an equation true, right, whenever it's equal. Now we're talking about a half plane that makes this equation true, this inequality, what we call a linear inequality, true. So any point in the shaded region or on this line will make it true. Now, as we look here at number 10, we notice that we are not in our y equals mx plus b form. I know I'd like to get it in that form, so what I'm going to do, looks like my y is almost by itself, so I'm going to go ahead and subtract 3x from both sides. So I'll end up with negative y is greater than negative 3x plus 2. Now I don't want negative y, I want it to be a positive y, so I'm going to divide by negative 1. Whoop, 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 whoop. Yes, remember, if you divide an inequality by a negative number, you have to change the sign. So this is going to be y is less than 3x minus 2. So now my y-intercept is down here at negative 2. If I want to think of my slope as being 3 over 1, it's a positive number, so I'm going to rise up 3, 1, 2, 3, and over 1, and get that one. Up 3, 1, 2, 3, and over 1. Or I can go down 3, 1, 2, 3, and left 1. So I've got 4 points on there, and then since this is just a less than, I'm going to be using a dotted line to graph this. Like so. Not a solid line or you'll miss points on this, but a dotted line. Now it says that y is smaller than that, so this is going to be everything below this line. So I'm going to shade down here. And again, what I've just said is that anything in this shaded region, this time not on the line, but anything to the right of this line or below the line, say, I don't know, this point right here where x is 3 and y is 0. If I plug that point in, or any point in the shaded region, it'll come out to be true. So let's see, is 0, is that really less than 3 times 3 minus 2? Is 0 really less than 9 minus 2? Is 0 less than 7? Well, yes, 0 is less than 7. So just like that point was true, any point in this region will also make that equation true. So I've done 2 of the 10 that you have to do on your worksheet. So good luck with the rest of those, guys. Good luck.